I'm just going to get started. We got 15 minutes. My name is Mike Toutonghi. I'm a former lead developer on Windows 95 kernel, founder of the .NET platform and chief architect, former technical fellow and chief architect of Microsoft's advertising platform, and a former CEO of the Web5 social network, later bought by Microsoft. I believe that the last 7 years of my role as a founder and lead developer of the Verus network in the Verus community will prove to be the most important and impactful work of my entire career. So this phrase, I've heard it a lot. I've heard it a lot over the decades I've worked in computers. I've heard it a lot. At Microsoft, people thought it was impossible to build a common language runtime, a VM, that would scale up to the largest and scale down to the smallest applications. But we did it. When we announced our launch, just before the Verus network went live on Bitcoin Talk, May 21st, 2018, there were a lot of impossibles in blockchain. You remember? A lot of impossibles. It was impossible to solve the 51% attack and stay decentralized. It was actually impossible to ever recover your funds if you lost your keys or you had them stolen. And when people invented and released DeFi, it was impossible to solve front running and back running and market abuse, all kind of bundled under the term MEV or maximal extracted value. It was impossible to solve until we did it in the Verus community. In fact, over the last 7 years, every single year we have released to mainnet again and again solutions that people have thought were impossible. So Bitcoin, for a lot of us, and maybe all of us, was a glimmer of decentralized light in the centralized cave that is our digital world. It proved that the world, the whole world, could compete in a permissionless way, and by competing could agree on a single currency, relatively low function kind of ledger, with people worldwide having self-sovereign ownership, fractional ownership on that ledger. Now, Bitcoin wasn't super complicated. In fact, the simplicity of the way that Bitcoin solved that was one of the things that was most beautiful about it to me, to many people. Unfortunately, Bitcoin didn't just keep moving. In fact, its innovation kind of slowed down, and you could say it ossified before it really delivered on the scale or the function that would be required to realize the initial vision. So what did people do? Well, Ethereum took kind of a different approach. They said, we need a virtual machine, we need a virtual computer, so everyone in the world can come and contribute to making this thing. So they put a virtual machine, a virtual computer, in the consensus of a single currency blockchain. And people came to build. So what did they build? Did they build a browser? No, although Brave integrates with. They built currencies. We kind of knew they would. They built IDs. They built DeFi. And they built NFTs and some apps with data. Mostly that's what people built. And then challenges ensued. So we had scale challenges. You know, I probably remember CryptoKitties. But there have been scale challenges again and again and again, and launch challenges. We've had hacks, billions of dollars of hacks, smart contract hacks, and one of the underappreciated weaknesses of the system that we continue to have hacks. Even just a few days ago, we had a hack that included a DNS redirect for millions and millions of dollars, phishing attacks. And we're going to talk about why in just a minute. But basically, instead of building primitives, the currencies, the IDs, and these things, the answer was build a virtual machine and everybody will come and build all of these things for us on top of it. But it was all based on best practices. It was not checked. The nodes didn't know what was going on. And so we had a lot of challenges. So what did we do differently in Verus? We said, okay, from a systems design perspective, that's just not the way to do it. We need primitives that are secured by the protocol. So we built currencies with DeFi. We built identities and data right into the core protocol of the Verus network. Now, the Verus network is what started it all, but we defined a name, Public Blockchains as a Service, or PBaaS, which refers to any of the permissionlessly launched blockchains on the Verus network. There can be an unlimited number of them, and they are all provably connected, and they are all independent. So I might refer to PBaaS chains or the PBaaS protocol as well as the Verus protocol. Mostly I mean the same thing. So who really controls your data and who really controls your money? Does anybody know where their data is? Where's your data? This is spread across data centers and different companies' data centers, right? Okay, so who controls your money? Well, in crypto you do, right? But let's talk about that for a second, because if I send a transaction from myself on the Bitcoin network, the Ethereum network, or the Verus network, and I'm sending Bitcoin, Ethereum, or Verus, and I send it to you, I make a transaction, it's got some inputs of currency, there's a transaction with outputs to you, and every single node on all of those three networks checks that there's no funny business, that the currency's going in or the currency's going out, and does the accounting for that transaction. But if I'm on Ethereum or any VM-based chain and I want to send USDC, or I want to send TBTC, decentralized Bitcoin, or I want to send another currency that isn't the single native currency of that chain, how do I do that? I give permission to a smart contract to take money from my wallet and do with it what it should, what I think it's going to do. But the first operative word there is permission. I give permission to a smart contract to take my money. So when I do that, that is what sets up for the phishing attacks that we have seen nonstop since this model has become available. Nonstop meaning every single week since this model has become available, phishing attacks, phishing attacks, phishing attacks. I don't have the time to tell you some experiences we've had, but how, I'm going to skip and talk about this in a moment. So on Verus, you never permit a contract to access your wallet. You don't permit anyone to access your wallet. This is your wallet. If you want to send, because we have currencies and DeFi built into the core protocol, Verus knows about all the currencies. It's not just a single currency blockchain that has VMs on top of it. It knows about all the currencies that run over it. So if you send USDC on Verus to somebody, or you send Bitcoin to on Verus to somebody, or Ethereum to somebody, you make a transaction, you have the inputs of that currency. Every single node on the network worldwide checks that all that you've done is correct, and the people receive what they should receive. If you put data in your ID on Verus, that data is encrypted. And if you want to share that data with an app, give someone permission to look at that data, or maybe you want to prove your age and not have to give away your name, you decrypt it and give permission to that app to take a look. You own and control your money and your data. Because all of these functions, the identities, the currencies and DeFi and data are part of the primitives of the Verus protocol, we've been able to solve MEV. We've been able to solve front running. You could say, well, that's a really impossible thing to solve because we've heard it every day. But the way that we solved it, I'll just explain it and then you'll understand. Every single transaction that is going to go through a liquidity pool or be converted on the Verus network, every single transaction that is mined or staked into a block, sometimes more than one block, because the protocol makes sure that miners and stakers don't actually know until the block is finished. Every single transaction that's going to convert currencies, say from USDC to Ethereum or Ethereum to Bitcoin or Bitcoin to Verus, all of these different transactions that go through a liquidity pool in the same block are solved simultaneously by every single node on the network, checked by every single node on the network, and every single transaction gets exactly the same price in all directions with no spread. So there's no front, and there's no back, and there's no front running, and there's no back running, but we do need arbitrage, we know that. And so the validators can in fact join, add their transaction to earn money on arbitrage. And when they do that, the dynamic is completely different. They're not front running you, they're not back running you, they're not Sam, they're joining you. They're bringing the prices closer to market and earning money as they do it, and it helps you. So that's how we solve MEV. And in fact, as far as we know, that is the only solution to front running and back running that's existed in DeFi or TradFi. But it's been running on the Verus blockchain and running absolutely fine for the last year or so, about $500 million, or a little more than $500 million of transactions through it. So what is this network running on? Whose data center is this network running on? How many ant miners do we need? How many specialty hardware systems do we need to run this network? And the answer is we don't. Because Verus was designed to run on PCs. It runs on Raspberry Pis, and it runs on Rock Pis, and that is what actually runs the Verus network worldwide, is people mining, staking, and running nodes on PCs, Raspberry Pis, Rock Pis, and phones worldwide. That's it. That's it. That is the Verus network, and that's why we call it commons-powered infrastructure. And commons-powered applications, which is work that we really put in to enable, are applications that they don't necessarily have to use a data center at all. They run on a client, and they can use the database that is the blockchain without having to write stored procedures that we can call smart contracts into that database. They can use that database as fully decentralized, scalable, back-end infrastructure. And they don't even need a data center to run their app on the client at all, the way that we've designed it. So this is a kind of a common theme in blockchain. The blockchain trilemma. And the idea is, with a blockchain, or with blockchain, you can't have great decentralization, great scalability, and great security all together. You gotta pick. You gotta pick one, you gotta pick two. But you can't have all three. We don't agree. And in fact, we don't agree at all, because the perspective you have to take for this to be a problem is, my chain will rule them all. You basically have to say, a single chain can't do all of these things well and serve the whole world. Well, guess what? Neither could AOL, and neither could MSN, and that's the phase we're in right now with blockchain. Mass market, the world, they don't really even know yet what we're doing. And the systems that think that they're going to be the one chain to rule them all. This is an AOL. This is an MSN. Time will show that's what these are. So Verus is a chain that runs the PBaaS protocol, and there are an unlimited number of chains that can just launch permissionlessly and run the PBaaS protocol across the Verus network. So what do these commons-powered apps look like? Well, I'm going to skip this because I'm low on time. This was the Web 2 architecture, basically showing you that you've got user presentation. Most of the logic and the data lives in data centers. And if you want to do payments or e-commerce, since it wasn't designed for that, you got a third-party payment processor that you're going to have involved. So how does smart contract fix all of this? Well, you've got a user using the app, probably through a web page that's served up from a data center. And that web page then says, hey, I want to do something with currencies, and user, give me permission to take your currencies and do something with them. And it takes the money, moves them around between contracts, and then says, hey, we're all done. And hopefully the money went where you wanted it to go. And if you're really dealing with the right app, usually it does. I mean, there could be bugs or things like that. If you're really dealing with the right stored procedure, the right smart contract, usually it does. But beware. Beware of phishing attacks, because this is still a very active and common exploit across crypto unless you're using Verus. The Commons-powered app architecture is an app that runs on the client. Optionally, you can have logic that runs in a data center. That's a transitionary thing for companies and app service providers to be able to do that as a transition. But the back end, the database, with all of the primitives, the currencies, the IDs, the data in the IDs, this is the blockchain. And it's not a single blockchain as an app blockchain. It's all the blockchains on the network for any of the apps. We actually think that an app is likely to work across many different blockchains, not a blockchain that serves an app. An app that can use all the blockchains and deliver value to users in a way that doesn't require them to take all your data, monetize your data. So if you want to send money, you just send it. It's just part of the protocol. You send it through the blockchain. It can go to the app provider, or the app can coordinate marketplaces. It can do all sorts of different things, but it's really much more like the model that we had in Web 2, much more scalable. We don't have scale problems, and it doesn't require that you have a data center running everything. So this is, I was going to mention the currency conversion. I think I'm basically out of time. A vendor can say they want to receive Bitcoin, they want to receive Ethereum, they want to receive Verus, and you send whatever currency you have, and because the DeFi is part of the network primitives, the conversion can happen as part of the payment. This is built in and works today. If you want to learn more about this, meet us at the Verus booth. I'll be happy to show you examples of all of these things. Bottom line is, my plea, learn about it. See your opportunity in building Commons-powered apps. Join the Commons-powered apps revolution. We've got fiat on and off ramp, metaverse, social messaging, private chatting applications, social applications, games, and others building on it right now. My time is up. Thank you very much. Appreciate all of your time as well.